So looking at another thin film problem, we've got N1 equals 23, N2 equals 30, N3 equals 7. All these numbers except the 30 were provided by my students. We've got a lambda of 550 nanometers provided by a student. And another one said, let's find the first maxima. So what is the thickness it takes to get to the first maxima? So start this problem. Start drawing some of your waves coming in, reflecting out, transmitting through, transmitting out, and see what you get. Okay, so let's take a look. We want to find the delta B minus delta A. If we look at the delta A up here, we're going from a low index to a high index, which does make this indeed a hard reflection. And hard reflections give us a phase shift of lambda over 2, 180. Down here, we're going from 30 to 7, so that is a soft reflection. So our delta B will always have the 2t, because we got to go in and then out, and it won't have any extra plus lambda over 2. That's it. So when we take these and put them down here, our change will be 2t from the delta B minus lambda over 2. And because Noah asked for the first maximum, this will be equal to m lambda, because we are looking for bright spots or maxes. Where do we take it from there? Pause the video and see what you get. So if we want to find a maximum, what might be the best thing to do first is just to put all of our lambdas together. So we can move this lambda over and just say, look, 2t equals m lambda plus lambda over 2. Because what we've been thinking in our mind is, should m equal 0 or should m equal 1? Which of these should it be? Well, we want to choose the smallest value of m such that we still have some thickness here. And in the prior examples we've done, or some of them, if we made m 0, the thickness would be 0. But this time, if we make m 0 and this goes away, we still have stuff left over. We can still have an object. So that's actually what we'll do here. We'll set m equal to 0. It kills this first part. And then if we divide by 2 on each side, whoop, whooshing, we'll find that our thickness will equal lambda over 4. Which, that is one of our two possible answers. It's either got to be lambda over 2 or lambda over 4. But wait, there's more! Did you forget? If you thought that was the end there, then you forgot again. Remember, this is the lambda inside the film. That lambda in the film, or lambda n2, is equal to the proper lambda in a vacuum, that's the 550 nanometers that were given to us, divided by N2, which was our film, which in our case was a giant 30 degree. We're like going through a diamond or something. But we need to make sure that this goes in here. So our true, like fully complete, like we feel super great about it answer is that the thickness is equal to lambda proper, the 550, divided by 4 N2. That is what we're actually looking for. Okay, so don't get hung up on that. Make sure you don't forget this, and make sure that whenever you're thinking about what m value do I use, do we still have thickness? What's the smallest number I can use and still have a thickness there? That will always give you your correct path. Okay, but this one is finished.